This is Note Taking Guide 2.5. We're going to do our factoring strategies today. So really what we're going to do is we're going to take everything we've learned about factoring and continue it in some new ways. So this first part is just a reminder of greatest common factor. So when we look at 5x squared and a negative 35x, I can see that they're both divisible by 5, and I can see that they both have an x in common. So I'm just going to factor it out. Really, I like to turn that into a multiply problem. What did I multiply 5x by to get to 5x squared? Well, I multiplied by x. And what did I multiply 5x by to get to a negative 35x? That would be a negative 7. So this would be factoring out the greatest common factor. This next one, if you look at the 2 and the 7, they don't have a number in common, but I do have two x's there, or x squared, that I can take out of both of them. If you think about it, you can say, what do you multiply x squared by to get to 2x cubed? Or you can say 2x cubed divided by x squared gives me 2x, and negative 7x squared divided by x squared gives me a minus 7. Either way, if you double check to make sure it multiplies back together to give you the correct numbers, like right here, 2x cubed minus 7x squared, then you know that you did it correctly. Alright, looking the 7, the 21, and the 14, I can see that they have a 7 in common because they're all multiples of 7. So I'm going to divide by 7. I'm going to be left with x squared minus 3x plus 2. And so I really just take out the greatest common factor. On this 8x cubed minus 40x squared minus 16x, I can clearly see they all have an x in common. And then I'm thinking I'm going to go with 8 here as my biggest number that will divide into all of them. When I do that, I've got to take out an x also. So let's put an 8x out front. What do I multiply 8x by to get to 8x cubed? That would be x squared. What do I multiply 8x by to get to a negative 40x squared? I multiply by a minus 5x. And what do I multiply 8x by to get to a negative 16x? I multiply it by a minus 2. We can do the same thing on this next one, looking for a greatest common factor. Everything here is divisible by 3, so I know I'm going to take a 3 out. That looks like the only thing I can take out here. So I'm going to take my 3 out over here. I'll be left with x cubed plus 9x squared minus x, and then minus 9 for my greatest common factor. This next type, again, is just greatest common factor. So again, look at your numbers and your variables and see what they have in common. Here I can take an 11x out. What do I multiply 11x by to get to 11x squared? That's x. What do I multiply 11x by to get to a negative 33x? That's a minus 3. Greatest common factor here, if I'm looking at it, they're both even numbers, so I know they have a 2 in common. And I can see that they both have x squareds. What do I multiply 2x squared by to get to 2x cubed? That's an x. What do I multiply 2x squared by to get to a negative 14x squared? That's a minus 7. It's still set equal to 0, so you could solve it if you needed to. This next one right here are difference of squares. We have a formula that says if we have a squared number minus a squared number, we can factor it by just doing the difference of the two squares. By taking the square root of the first number, the square root of the back number, and doing one with a minus and one with a plus. So 49x squared will square root to 7x, and 4 square roots to 2, they're perfect square numbers. We're going to make one of them a minus sign, one of them a plus sign, and we're in factored form. This next one doesn't look like it's a difference of squares right now, so let's see if we can make it look like it. Remember, the very first thing we always look for on factoring is a greatest common factor, and I can see that these are both even numbers. So I can take out a 2, and they both have an x in common, so I'm going to factor out an x. So what do I multiply 2x by to get to 8x cubed? That would be 4x squared. What did I multiply 2x by to get to a negative 2x? That would be a negative 1. So right here now, I can totally factor this other part out because it's now a difference of squares. I still have the 2x out front, but that 4x squared square roots to 2x. And the 1 square roots to 1, one of them is going to be minus, one of them is going to be plus. The next kinds of problems are sums and differences of cubes. So what we're doing is we're looking for perfect cube numbers added together or perfect cube numbers subtracted together. When we find them, we're going to put them through these formulas with our a and our b values. The a value comes from cube rooting the front number, and the b value comes from cube rooting the back number. So I'm going to identify my a and my b here. My a comes from the cube root of x cubed, which is x. And my b comes from the cube root of 343, which is 7. So then I just take it and I plug it into the formula that has the minus sign in it, which is right here. So it's a minus b, which would be x minus 7, a squared, which would be x squared, plus a times b, which would be 7x, plus b squared, which would be 7 squared, which is 49. Okay, same thing here, but this time it's a plus sign. So identify your a value. It's the cubed root of 8x cubed, so 2x. And your b value is the cubed root of 27, which is 3. We're going to plug it through our formula that has the plus sign in it, so this top one this time. And we're going to have 2x plus 3, and then 4x squared minus 6x, because I multiply my a and my b together, and then plus 9 if I follow the formula. This last one right here that we can see has an x in common that I need to factor out first. So I'd be left with 64x cubed plus 1, and then I could refactor this part as a perfect cubic. 64x cubed would be 4x, 1's would be 1, and then I just still put it through my formula. So 16x squared. When I multiply those together, that would be 4x, and then square the back one, which would be 1. This next one down here has a 2 in common first, so I need to factor out the 2 first before I can put it through a perfect cube. So if I do 432 divided by 2, I get 216. So 216, and then I can totally factor this as a perfect cubic. 216's cube root is 8, maybe 6. There you go, my second guess was right, it's 6, so it's going to be x plus 6, then it will be x squared minus 6x plus 36. For my factored form. This next section is what we do if we have 3 terms in a quadratic. So when there's a number 1 out front here, we can really just factor it. We're going to find 2 numbers that will multiply to a negative 36 and add to 5. So I would list my factors of 36, so 1 and 36, but those won't add to 5. 2 and 18, those won't add to 5. 3 and 12, those will not add to 5. 4 and 9, oh look, I can get those to be 5 if I put a negative on the 4 and a positive on the 9. So I'll have x minus 4, x plus 9 to factor that. This next one works the same way, but before I can do anything, I have to factor out the greatest common factor, which is a 2x. So when I do that, I'm left with x squared plus 5x minus 14. And then I'm just going to factor this last one the exact way I did the last one, where I multiply to a negative 14 and add to positive 5. 2 numbers that will multiply to 14 and add to a positive 5 would be a positive 7 and a negative 2. So plus 7 minus 2. So what do we do when we have a power of 4 here with the number 1 out in front? Well, we're going to separate this just the same way we did, but we're going to have to do x squared and x squared instead of x and x to get to the x to the 4th. We're still going to find numbers that will multiply to a negative 12 and add to negative 4. So we could just list them 1 and 12, 2 and 6. 2 and 6 looks like they'll work if I put a negative on the 6. So I'll have x plus 2 and x minus 6. Neither of these factor further, so I'm done right there. This next one works the same way, but before I can factor it that way, I do need to take the common factor out, which is a 2. So I'll have x to the 4th plus 7x minus 30. And I'm going to just factor this one then the same way I did the other one. Separate that x to the 4th as x squared and x squared. And then I'll find my numbers that multiply to 30 and add to 7. So probably 10 and 3. I need them. I need the 10 to be positive and the 3 to be negative in order to work. So I'll have x squared plus 10 and then x squared minus 3. So this would be my factored form right here. All right, this next one right here then asked me to factor and solve. So I'm just going to separate those into two factors like I did just a minute ago. I'll have x squared and x squared. I'm looking for numbers that will multiply to 4 and add to a negative 5, which would be a negative 4 and a negative 1. So this works out pretty cool because these both now are a difference of squares, which means I need to factor them further. X square roots to x and 4 square roots to 2. One's going to be a minus, one's going to be a plus. X squared square roots to x and 1 square roots to 1. One will be a minus and one will be a plus. So when I set these equal to 0, I bring them out as the opposites. So I have x equals 2, negative 2, 1, and negative 1. All right, this next one right here is a new kind of factoring that you haven't seen yet. It's called factor by grouping. So what we're going to do is we're going to factor those first two together and factor those last two together with a GCF. So what do these have in common? They have a 3x cubed in common. So let's factor it out and see what we have left. Here we'll be left with x, and here we'll be left with 6. Then in the middle here, we're going to factor out the greatest common factor, which is a 4. When we factor out the 4, we're left with x minus 6. When I get these to be the same inside the parentheses, that tells me that I did it correctly. Then it just becomes a matter of rewriting it. I'm going to write the 3x cubed together with the plus 4, and then I'm going to only write the x minus 6 once. The reason I can do that, this one has to be distributed to both of those. This one has to be distributed to both of those. But if I write it this way, it's still distributed to both of them. It's just written in a nicer form. So this would be my answer right here. Same thing happens on the next one. So factor the first two together, factor the last two together. We're going to find a greatest common factor. So here the greatest common factor is x squared. I'll be left with x plus 5. Here I'm going to factor out a negative 4 because of the sign right here. When I do that, I'll be left with x plus 5. That tells me that I did it correctly because my x plus 5s are the same. So I'm going to go x squared minus 4 times x plus 5. And then I'm just going to factor this one a little bit further because that one's now a difference of squares. So I'd have my x plus 5 from here. And then this factors to x minus 2, x plus 2. And if I had to solve that now, I could totally just factor those out. I knew I was looking for 3 answers there because my power of 3. All right, so this one says to factor by grouping. And oh, it says, what do we do when factor by grouping doesn't work? Well, that's just a reminder when that doesn't work. We're going to find the factors of this. So 1 and 48.